Hello dear students, welcome you all once again to a game changer program for the NEET 2024 aspirants. In 10 days, on behalf of Sri Chaitanya Educational Institutions, myself Pavan Kumar Kasu is going to give you the inputs, the most important inputs related to the learning of chemistry in a quick time. So we are not here assuring you 100% that these are the questions which would be asked to you in the coming NEET examinations. However, we want to tell you that the questions will be similar, asked from the older concepts only. They are mostly NCERT oriented. If you look at the last year question paper, more than 55% of the questions are directly or indirectly asked from NCERT textbooks or your board textbooks alone. So, in coherence with the board preparation, when you carry your preparation for the NEET, definitely your chance of conquering would be higher. With that aim and object, in order to fasten your preparation standards as well as the quality, we have decided to come up with a program in these 10 days how to enhance your preparation skills. As a part of this, you know the schedules, you know the timings which you need to regularly follow, and I'll be here with you from 4:30 to 5:30 p.m. discussing the chemistry. And you know that if you look at the previous year papers, chemistry had not been so much easier. This clearly suggests us to concentrate a little more on chemistry and score as much as possible, because you guys are anyways good at botany and zoology. Your aim and object should be to score as much as possible in chemistry. So let's do that. Let's start the session by discussing some more questions and versatility in answering them. I welcome you all once again to the chemistry session, starting with a question from organic chemistry. Look at the question. The question is based on the categorization of the compound, isn't it? Now you have been given an alkyl halide, isn't it? This is not aryl halide, because halogen is not connected to the benzene ring whatsoever. You can see halogen is connected to the side chain. So certainly we can say that this is an alkyl halide. The point is, how do you mention this when it is alkyl halide? What category it is? Obviously you said that it cannot be aryl halide, because aryl halides are the compounds in which halogen is directly connected to any of the position of the benzene. So this is not aryl halide, isn't it? Ruled out. Vinylic halide, you know that the double bonded carbon is attached with the halogen in vinyl halide. What else do we have? Allylic halide, you know that the adjacent to the double bond or the alpha to the double bond is what you call as allylic halide. And benzylic, you know that benzene adjacent position when occupied by the halogen, you call it as benzylic. So when you are sure about these positions, good afternoon and welcome you all. Good evening, welcome you all. All right, Varshini, you are there, right? So you can see that the given compound is not benzylic. You can see this halogen is not over here, is not aryl halide because the halogen is not connected to the benzene ring. Then what do we have? You can see clearly that there is an alpha position adjacent to the double bond which is carrying the halogen. Hence the right answer should be, like Varshini, you said D. No beta. All right, you can see that that is allylic halide. I told you vinylic halide has the halogen attached to the double bond itself. Please understand this. No confusion, isn't it? Acha, Varshini, you said C, and in some other comment I could see that you said D. Or which one is right? Divya said C. Which one is correct over here? If you have made a mistake, immediately correct, because you have 10 more days to go until your final preparation gets over. So you please correct yourself here. There should not be any confusion between vinylic, benzylic and allylic. Vinylic double bond carbon is attached to the halogen, allylic adjacent to the double bond, benzylic adjacent to the benzene, aryl on the benzene. Alright, so no confusion. So the answer to this question should be what? Acha, by mistake you said D. That's okay. Anyways, you corrected yourself, but you know the concept, that's more important, isn't it? Good job. Let's move on, isn't it? You can see this is what you can say is somewhat related to the biomolecules which cannot be ruled out. Okay, when it comes to the chemistry in everyday life, that chapter is deleted, isn't it? But biomolecules plays a significant role where we are talking about nucleoside and nucleotides. So you may be wondering, sir, will that be a part of the chemistry in everyday life also? Because you see, most of the carbohydrates, amino acids and proteins we have associated with our daily lives, isn't it? So we might think that the carbohydrates, amino acids and proteins are not the part of the syllabus, assuming that they are present in chemistry in everyday life. It's mandatory for us to distinguish the biomolecules from chemistry in everyday life. Like if you remember in yesterday's session, I have discussed about tranquilizers, isn't it? Where you have seen barbitals are given and which of the following is the tranquilizer was the question, and we had to discuss some questions from the deleted portion because you are also simultaneously writing the other entrances where the syllabus is not reduced, isn't it? But today I will ensure as much as possible the deleted portion is not being discussed with you. So let us concentrate on the existing portion, in which you can see this is a statement based question, and you know in NEET examination majority of the questions are statement based and time is less, so you need to read each and every statement very carefully. It says that a unit formed by the attachment of a base to the first position of sugar is known as nucleoside. So side chain attached to a base. This is how one has to remember when we talk about what you call the first position of sugar. That means when we are talking about what you call the furanose structures in the sugars, in that case you know that this is the first position which we are talking about, and when it is attached to a base sparing the other position, you can see you have, all right, the other positions available. Okay, so it could be the furanose structure or pyranose structure. When you are talking about the furanose or pyranose, you can see here clearly, if you are talking about the furanose structure, the fifth position is over here, all right. If you are talking about the pyranose structure, that pyran means it's a 6-membered heterocyclic ring, isn't it? You can see that the positioning is done like this, so no confusion whatsoever. So fifth carbon is part of the ring if it is a pyranose structure, fifth carbon is in the side chain if it is a furanose structure, all right. So you can see that, okay. So let's talk about this, it's important one. When the side chain attached with a base, obviously it's called nucleoside, right? So statement 1 looks to be all right. And majority of the student here neglect the biomolecules. I must tell you that there are definitely 1 to 2 questions asked from this topic which are upfront asked from your NCERT or board textbook. So do not miss at any cost. If you read the board textbook, you will be able to attempt these questions 100%. So believe me, don't skip reading just the NCERT textbook. You don't do any extra things. Just concentrate on NCERT textbook and it's very easy scoring there. And you can see when the nucleoside is linked to a phosphorus acid at 5th position of sugar moiety, we get nucleotide. This statement is contradicting at some point of time, isn't it? All right. So please understand here, concentrate on this. You would see that when this 5th position which we are talking about is attached to the phosphate, I will discuss with you. Let me get back to you, Bhargav. Now listen, when we talk about the phosphorus acid and phosphoric acid, you guys can see that when you write the structure of phosphoric acid, you see this nobody explains you or you doesn't focus on this much, so please concentrate how you get the phosphate link. Now we can see H3PO4, I am writing phosphoric acid, not phosphorus acid. Alright, so you can see what is left out, H3. Alright, you have what? H2PO4. Alright, so you can see that when I am removing H2O from this unit, I know I would be getting what you call the phosphate link after the removal of water from it. So it is orthophosphoric acid but not phosphorus acid, which is involved in the dehydration at 5th position in order to form a nucleotide. It's a small scope of error. It's mentioned as phosphorus, rather it should be phosphoric. Alright, so statement 1 is true but statement 2 is false. Alright, so it's a phosphate unit that is adjoined to the sugar moiety in nucleotides. Remember this. Our next question is about the intermolecular forces, isn't it? Now you can see there is a query coming from one of the student. Bhargav says how many questions are asked usually from chemical bonding. Listen to me, you need to understand that periodic properties and chemical bonding need to be regarded as one unit. Chemical bonding and periodic classification and properties. Clubbing them together, there are chances of minimum 3 questions. So when they ask you that question, they might also combine some S block elements or P block elements about hydration energy or something. So on the whole, periodic properties and chemical bonding, I expect minimum to maximum 3 questions. So do not ignore that, it's an important chapter. Alright, now look at this. We are talking about intermolecular forces. That means the forces between the molecules. If it is within the molecule, you call it as intramolecule, isn't it? Okay, Varshini, can you hear me? Alright, so listen to me now. When we are talking about intermolecular forces, dipole forces. If you look at HCl, you know there is a certain quantity of polarization present in the compound because of the electronegativity difference. So when one HCl molecule gets in contact with another HCl molecule, we anticipate the opposite charges to attract each other. So the plus and minus of one molecule attracting the minus and plus of the other molecule. So dipole forces obviously are intermolecular forces, isn't it? Next you have induced dipole with dipole. That means when you take HCl molecule closer to any molecule that doesn't have any polarity. Okay, alright. For example, I have brought close O2 molecule. You know that the polarity present in HCl will induce the polarity in oxygen. So there is no polarity present, there is no electronegativity difference in oxygen, but it is induced by the polarity over here. For example, you are engaged in a serious study. One of your friend who is not very serious about studies trying to distract you, you might get distracted. There are chances. So I suggest you not to get distracted when somebody is disturbing you in the form of comments, and don't do that, right? These are free sessions meant to help the students who are struggling with the fundamentals and who are very serious about their dream career goal. So I earnestly request you sincerely that if anybody is not interested to attend the session, so don't waste your data, don't waste your resources, don't waste the battery of your cell phone. Keep it, watch something else. Please pay the students who are watching the classes very seriously, because you are polar, he or she is non-polar. There are chances that they might get distracted. So they are also intermolecular forces. So this is second category. Coming on to the third category, hydrogen bonding. You know that in hydrogen bonding, when we talk about the intermolecular hydrogen bonding, you could anticipate here the forces between the opposite charges of hydrogen attached with oxygen, fluorine or nitrogen with these elements itself. This is called as hydrogen bonding. You know that it is intermolecular force, isn't it? And dispersion force or London forces that exist between any two surfaces, that is also called as mutual polarity induction forces. That means these two units independently are neutral, but when they brought in contact, the positive of one molecule will attract the negative of the other. They looks to be neutral, but they induce polarity in each other. So that's called dispersion force, van der Waals force or London forces. They are also weak, but they are between the molecules. You know that you have studied that they are also intermolecular forces. What is not intermolecular force? What lies within the molecule? Like if you look at oxygen, you know that there are covalent bonds. So within the molecule is covalent bonding, and all the other bonds, dipole, dipole, dipole induced dipole, hydrogen bonding, everything is actually what? Intermolecular forces, isn't it? So you need to understand that the right answer for this question would be, all right. So I hope you're following up, isn't it, Varshini, like yesterday? Rebecca, Bhargav, can you hear me, buddy? Rasagna, Divya, are you there? Catching up with the class, isn't it? So what should be the right answer? Right answer for this question is option C, isn't it? Except D. All right. So what you have to do is, you can see there is only one option. In every other option, D is present, and you know D is not intermolecular force. So even you can do the elimination method, isn't it? It's very easy. Elimination methods are much easier. D is present in rest of the three options. When I rule out, obviously C would be the right answer. So instead of hovering around all the options which are given, why don't I use this simple technique? Because I need to solve the question in less than 1 minute time. I should also know how to get the answer very easily, quickly. So do that. D is ruled out, but D is present in all the options. So blindly I can attempt C. Vaishnavi, good job. Moving on further, related to the hydrogen. All right. Now hydrogen is again, you're having fun when I'm discussing what you call when the question strikes from the deleted portion. You know, hydrogen is deleted. All right. So it doesn't make any sense in discussing related to it. But still I want to give you a quick glimpse, because at the end of the day, if any question is asked, we should not get blamed for anything. So let's see, hydrogen is used to reduce heavy metals, isn't it? Because reduction potential of the heavy metal is greater than that of hydrogen. A looks to be the correct statement, but you can say not correct. Heavy water is used to study the reaction mechanism. Always remember, when you compare the water and heavy water, you know that the bond in heavy water breaks difficultly. So rate is slower with heavy water. So we can compare the rate of the reaction. Correct statement. Hydrogen is used to, we know that, right? Saturated fats from oils. Hydrogenation reaction. Correct statement. Hydrogen bond energy is not lowest, because it is formed by the direct overlap of two spherically oriented orbitals, s orbitals. So the bond is very strong, isn't it? So it's not so weak. So this is a wrong statement. Hydrogen reduces the oxides of the metal which are active. How can it be? You know that active metals are having more oxidation potential. You can't expect this to take place. It's not possible. This comes in electrochemistry. What do we say? Whatever is the reducing agent should be more active than the metal itself. You know that active metals are active. They cannot be replaced very easily from the solution. So this statement looks to be incorrect. All right. So you have to find out the incorrect statement. So right answer would be option C. Again, let me see how many of you have marked it correctly. Uttej got it right. Rajalakshmi got it right. Brilliant. Some good new students have joined in today's session. Good to see when there are pouring answers, right? Good job. You can assess yourself how exactly your preparation is. This is a crucial stage. This will boost up your confidence levels. Alright, you are writing an exam which is appeared by around 20 lakh people. Competition quantitatively is very huge. Boosting up your confidence level is mandatory now. So please be active in your sessions and try to give the answers as much as possible. You are giving great answers. Keep it up. Alright, theoretical question. Boring, isn't it? You know that daily requirement of magnesium and calcium in human body is expected to be around 200 to 300. I googled it to see. So there are some questions for which only Google will be the answer. So that's a theoretical question. Alright, that itself says that remaining are not correct. And moving on further, like you know that when the syllabus of portion is deleted, they also emphasized that the general trends or general properties remain intact. They did not delete it, by the way. So this question is related to what? The general trends of the p block element in which carbon is highlighted. You can see coke. Carbon in the form of coke can be used as a reducing agent. You see, when you are sitting in the examination hall, it's a challenge. Okay, after the examination is over, I know you guys can simply give the answers to the question. Even you can do that. But in the examination hall, facing the pressure, getting the right answer will be challenging. Excellent. Vaishnavi and Varshini, neck to neck competition. Good job. Coke can be used as a good reducing agent. You know, diamond carbon atoms are sp3 hybridized. We used to study. Fullerene is cage like C60. Buckminster fullerene, isn't it? Good job. Graphite is dry lubricant. All right, you got it right. Option C. Let's check. A is 3. Yes. B is 1. sp3 hybridized. Graphite is sp2. Diamond is non-conductor. Graphite is conductor. Graphite is thermally more stable. Diamond less stable. Remember this. Option C. Brilliant. Rajalakshmi got it right. Next question. Stoichiometry. As soon as stoichiometry comes, psychometry comes, isn't it? But not like that, right? Stoichiometry is most interesting chapter that you would ever come across. Questions are very easy. You see, this is where you need to score over the others, right? Stoichiometry is difficult for the others, difficult for you. Ionic equilibrium is difficult for others, difficult for you. Where you have an upper edge, then you need to have upper edge over the others in some chapters like stoichiometry. Prabhavati gave the answer. Wow, you got it. Let's see. Rajalakshmi also got it. You see, just attempt it like anything, right? See, when you are asked the questions related to the mole concept, let me tell you something which is very important, buddies. See, we are solving the questions on what? Mole concept. In the mole concept, what you have to do is, listen to me carefully. First, you have to balance the equation. Number 1, write the reaction. Mostly they will give you the equation. What you need to do is balance, and they will ask you the question on balancing also, which we are going to discuss in the coming time. Uttesh gave the right answer. Next, convert the mass into moles. You know, number of moles is equal to weight upon molecular weight, or mass by gram molar mass. Then apply the reaction stoichiometry. Use the stoichiometric coefficients to find the moles of other. This is how we proceed. To find moles of what? Others. Let's see how this goes, isn't it? All those students who have not studied stoichiometry properly, please listen. You can see we have got 20 gram of 20% pure limestone. Limestone is CaCO3, isn't it? So 20 gram indeed we have taken. You have checked whether the equation is balanced or not. It's balanced, but it's only pure by 20%. All right. So it's only pure by 20%, means only 4 gram is pure. Mass has to be converted into the moles by dividing with the molar mass of CaCO3. 40 plus 12 plus 48 seems to be 100, and better you remember the molar mass of CaCO3. Majority of the question it is asked. CaCO3 ka molar mass is 100. So you guys can see here that this value is turning out to be how much? Whatever. Alright, so whatever you get, you have to convert that into the mass of what? CaO. Let's see how to do that. 1 mole, this many mole you got, right? 1 mole of CaCO3 giving rise to how many mole of CaO you need to find out. 1:1 is the ratio. If these are the number of moles of what you call CaCO3, the number of moles of CaO also would be the same. How much? The same. Alright, so 2 you cancel off. Alright, 5 times 1/25. So these are number of mole of CaO, and you know mole means molar mass of CaO, that is 1/25 into 56 gram. So this should be the right answer. Like how much you got? When you simplify this, probably you will get your answer exactly. Alright, how much do you get? Please do the calculation and let me know. Did you get version B? Is it turning out to be 1.56? Is there anything wrong? Could you please check? Any calculation mistake? 20% and 20 by molar mass, 1/25, and molar mass of this is 56, and this is 2 point something, isn't it? What do you all say? Isn't it, buddies? Where are things going wrong? What matters is finally the calculations, right? Though I am leaving it to you, you need to be attentive while doing the calculation part. Alright? Next, identify the product in the following reaction. You guys can see this is Sandmeyer reaction, right? Sandmeyer reaction is very popular reaction. Named reactions are frequently asked in these entrances. Named reaction like Sandmeyer, you have Reimer-Tiemann, you have Rosen-Mund reduction, you have Sabatier-Sanderens reaction, Wolff-Kishner, Woods reaction, Kolbe electrolysis. Better you recollect all named reactions. Named reactions are very important. Mostly emphasized. It's not that they will ask you which of the following is a Woods reaction. Be careful, alright? Ashwak. Now you see, when you have taken this compound and treated with cuprous bromide or cuprous chloride, you all know that what you're going to get. This entire group will go, nitrogen will go, and you will be left with what? Bromine, isn't it? What do you call that reaction as? What is that reaction, buddies? Sandmeyer reaction, isn't it? Where diazonium salt will be replaced by a better nucleophile. It could be bromine, chlorine, or cyanide. Anything it could be. Remember this. After that, magnesium would convert that into what? In presence of ether. What's the product? Can anyone tell me? Any guesses? Grignard reagent, isn't it? Your all-time favorite, very widely asked. And after that, you see, you can either do the steam distillation or boil it in presence of water. It could be mentioned as steam distillation. Remember, anything can be given. Or just heated with water. This whole group, Anish, will be replaced by, alright, very good, excellent. Congratulations, Anish. So what is that you are going to get? That whole group will be replaced by the OH we have studied, isn't it? Alright, so what is the answer for this question? Come on, speak out. Version is at C. Sandmeyer, you don't know, Vaishnavi. Sandmeyer is nothing but the conversion of diazonium salt into the halo this thing. Yes, Prabhavati, you are right, perfectly alright. Have you understood all? I think you are following up, isn't it? Okay, good job. Alright, shall we move ahead? Yes, Rajalakshmi, that's a good answer. Chalo, let's see the next question. Electrochemistry question. Little bit theoretical. Can anyone answer what exactly is the intensive property? Could you please tell me? Intensive property is the property that is I for intensive, I for independent of the amount of the substance which is present in it. All right. You need to understand that when you talk about the EMF of the cell, yes, good. When we talk about the quantity, this does not imply the concentration. Please understand the question. Many sources on the internet had given the solution, but without the proper explanation to this property is called as intensive and extensive. When you watch the videos, they'll just say the answer is A, the answer is B and all that stuff, but they won't give you the reason why. Let's try to assess. Let's try to connect the intensive properties with electrochemistry, although they are the properties associated with thermodynamic properties. How do we connect these two? Let's try to understand. This is very important. Independent of the quantity of the substance. Now, when I am talking about the substance here, it means the solids. All right, because for solids, we consider the active mass, that is concentration, to be always equal to 1. So, when you write the Nernst equation, for example, you are writing the Nernst equation, right? Nernst equation you all know. When you are writing a particular reaction, for example, say zinc is getting reduced in a particular case, when you write the EMF of the cell, E0 minus 0.06 by number of electrons log into this concentration would be taken as 1, only this is regarded. So, this is the context or reference of the statement. This is what it means by being independent. Yes, Anish, brilliant. But have you understood why this what you call EMF of the cell is an intensive property, buddy? I hope you all have understood. This is very important. Alright, so this statement I was trying to emphasize. EMF of the cell is intensive with respect to the solid components that are taken in the electrochemical cells. Alright, and delta G is an extensive property. You know that delta G speaks about the spontaneity, occurrence, the probability of occurrence of a process depends upon the amount of the substance that you take. If you take more substance, more product may be formed. Yes, brilliant. So, this looks to be all right. And delta G depends upon N, of course. But you see, nowhere these two sentences are looks to be connected to each other. Where N is not the amount, N is number of electrons, isn't it? So, right answer. See, assessing here between A and B is very important. Yes, Varshini, brilliant answer. So, it's B. If you look at some of the websites which have published the key, they have mentioned it as A. Have you noticed better? Anish, going good? I hope you guys are following up, isn't it, Vaishnavi? So, right answer for this question is option B, isn't it? Yes. Rajalakshmi, Prabhavati, are you there with me? Good. Chalo, let's do some organic chemistry rearrangements. You can see HBr is being taken, right? When you have the compound, please zoom into the functional group. Always zoom into the functional group. When you are especially talking about the what you call the reaction oriented questions, we might panic. First, what you have to do is zoom into the functional group. What chapter is that? Then you see the reagent. It is an alcohol. Reagent is HBr. When you add HX to the alcohol, you will be getting alkyl halide, isn't it? Now, what happens here when you take what you call HX to the alcohol? The question arises, when do I get rearranged product, when I don't, isn't it? Remember, only when you take the alcohol and HBr, there are chances that you might always get a rearranged product, because you see, when this OH adheres to the H plus, when it attaches to the H plus, this suddenly becomes a great leaving group, because there is a positive charge on the oxygen which it cannot tolerate. Yes, you are right. Solvent plays a major role, but nothing had been mentioned about the solvent, Anish. Isn't it in this question? So you need to understand that when you take alcohol and when you add HX, there are most of the chances forming the carbocation, irrespective of the solvent. So you get a carbocation. You know the stability of carbocation lies like this: benzylic, allylic, tertiary, secondary and primary. Alright, so even if you have a chance of forming a primary carbocation, it would be formed maybe later rearranged to the 3 degree or secondary. Please understand this. Carbocation will be certainly formed when your alcohol reacts with the HX. So what is happening here, that you will be getting a secondary carbocation which would be definitely formed. And later on, when I am migrating this hydrogen over here, there are chances that your secondary carbocation is converting into what you call tertiary, which is more stable than secondary. So rearrangement products are very much possible here, isn't it? So what should be the right answer for this question? No, Br minus would come and attack over here. So rearrangement had taken place, isn't it? So these questions are frequently asked. Have you understood the concept? Yes, Rajalakshmi. The right answer is A. Good. See, we generally get tempted to write the other products, but you can see clearly it is ruled out, right? You can see here this is non-rearranged product. Here we got methyl group extra and it has moved to the primary. How can it be possible? Isn't it? And something is missing over here, and looks to be that, look at this option, this clearly says that it's a rearrangement product, and rearrangement products are quite obvious in almost all the reactions related to the alcohols, whether that is addition of HX or dehydration. Dehydration is another topic from where the rearrangement products are expected. So please be careful. From alcohol, these two questions and these two topics are frequently being covered, apart from the iodoform reaction and oxidation by using Jones reagent. So please emphasize these 4-5 topics more when you are particularly studying alcohols. And another important topic is being what? Aromaticity. Alright, you know that when you take the cyclic compounds, so I am trying to elaborate, instead of just giving you what you call the inputs related to the solution, I just want to give you the input related to the concepts also. You know that these cyclic compounds are basically divided into aromatic, which are regarded as most stable in comparison to the non-aromatic, isn't it? Which are indeed more stable than anti-aromatic compound. Alright, so this is the stability order. Sometimes we get a doubt, sir, why this stability order, isn't it? Anish says that this has 4 pi electrons, 4n pi electrons. Questions not visible properly. Yeah. So you see there is some sort of like, zoom. Please zoom yourself. I am not able to zoom it over here. Alright. So I will draw the structures for you, Anish. Don't worry. First, let us talk about the stability. Can anyone tell me why the aromatic compounds are most stable in comparison to the non-aromatic and anti-aromatic? I am expecting the answer from you all. One speed up conceptual discussion. Waiting for you. Why aromatic compounds are more stable? Planar structure could not be the reason. Even anti-aromatic has resonance. Anti-aromatic has resonance, that I knew, that's why I said. Here the point is, listen to me buddy, not that Prabhavati, let me tell you. Pi electrons, you see when they are involved in resonance, you call here the number of pi electrons are 4n plus 2, alright. Here the number of pi electrons are 4n, involved in cyclic delocalization, which you are calling as resonance. Cyclic, in a cycle, in a ring, they must delocalize. If they are delocalized outside the ring, that is not valid. That's why planarity matters. So these pi electrons are present in the bonding molecular orbitals in these compounds with lesser energy. They are present in the non-bonding, these are called BMO, These are called non-bonding molecular orbital. These are called anti-bonding molecular orbital. So you need to understand here that energy lies in this order. So electrons are present in BMO when it comes to the aromatic, NBMO also in non-aromatic, and ABMO in anti-aromatic. So as energy increases, stability decreases. Alright Nandu? So this is the actual reason. Alright, so one should know about the stability order also. Now 4n plus 2 pi electrons, when you add that n could be anything, over here n equal to 0 means 2 pi electrons involved in cyclic delocalization, 6 pi electrons, 10 pi electrons, this is the species which is aromatic most stable. Yeah, now you got it, isn't it? Now you got it, Anish. So anti-aromatic 4 pi electrons, 8 pi electrons, 12 pi electrons, they are involved in resonance. Now look at the compounds which are given to you. Alright, now let me erase entire this thing for you. Now look at the structures which are given, I will draw them for you again. One is naphthalene. Listen to me carefully. The one compound which is given is what, buddy? Naphthalene. You see, all the carbon atoms are present in a ring because hybridization is same. How do you ascertain the planarity? Coplanarity is same hybridization. Remember, when hybridization is same, planarity exists. You can see all the carbon atoms are sp2 hybridized, so coplanar. They will involve in resonance. How many pi electrons are there? 3 pi bonds, 2 pi bonds, total 5 pi bonds. That means 10 pi electrons are involved in cyclic delocalization. Hence, the first compound, that is naphthalene, is regarded as aromatic. Alright. Second compound which is given to us is cyclopentadienyl anion. Alright. Yes, that's the purpose of these sessions, and thanks for the appreciation, buddy. Now listen, cyclopentadienyl anion. Look at this. There is coplanarity. There are 6 pi electrons involved. Cyclic delocalization looks to be cyclopentadienyl is aromatic as well. Next you have cyclobutadiene. It has resonance. Sometimes resonance kills. Anti-aromatic. Okay. Next, you have the cyclopropenium anion, 4 pi electrons and cyclic delocalization, resonance. It is also anti-aromatic species. Next, you have cyclopropenium ion, cation. It is having 2 pi electrons and resonance, aromatic species. You can see it falls under this category, 2 pi, 6 pi, 10 pi, etc. Next you have, listen to me, the most important case. I think this you understood. Shall I erase all this? Vaishnavi, what do you say? Shall I erase this example? You understood? You have any doubt in this? Because some more I need to, yes, chalo, good. Some more examples I have to work out. Let's see them. Yes. You see the problem with this. You see what is the problem over here? It is cyclooctatetraene. It acquires a distorted tub shape instead of being it like this, for the reason this bond is out of the plane from the remaining bonds. It is not in the same plane, it is slightly tilted. For the reason that this many pi electrons, 8 pi electrons in a ring cannot be accommodated, can't circulate properly. So that is the reason why they go out of plane to adjust yourself. See, you're sitting in a very crowded transport facility bus, then definitely you are adjusting your seating so that you feel comfortable. It's overcrowded bus. So that is the reason why this goes out of plane from the remaining position. So obviously one could anticipate here the planarity to be lost. Distorted tub shape, anticoplanar. So there are 8 pi electrons, but unfortunately there is no resonance. Hence, this compound is regarded as non-aromatic. So, this is the exceptional case, isn't it, Nandu? All right, good. Then lastly, you have anthracene, which has anthracene, you can see that having 14 pi electrons. All right, 14, isn't it? 3 plus 2 plus 2, 14 pi electrons. That means it falls under the category of aromaticity. Total number of compounds are naphthalene, cyclopentadienyl anion, all right, cyclopropenium ion. Then you have this. So, right answer, like you all said, brilliant. All right, buddy. Now look at this. What's this reagent? What does come into your mind when you look at this reagent? You tell me. One popular reagent. Can you see that? Can you see that? Varshini, Nandu, Tollens. Look at Anish. Brilliant answer, right? Tollens. And Tollens reagent clearly distinguishes aldehyde from the ketone, isn't it? You know, Tollens is a mild oxidizing agent. And when it comes to the reactivity, aldehydes react with mild but not ketone. That's the reason why we distinguish aldehyde from the ketone. Brilliant. So, now you have one aldehydic group and one ketonic group. You know, it oxidizes only aldehydic group. Oxidizes but not reduces. So, this is ruled out. This is oxidation only. But you can see in basic medium there is no point of obtaining the acid. It is all right. So, right answer would be oxidation with a negative charge. Is it understood? Oxidation of aldehyde with a negative charge, because you will get salts, not acids. All right. Okay. Next. Yeah, it's a theoretical question once again. Look at this. All the transition metals except incorrect statement you have to identify, except MO oxides which are ionic, except scandium forms metal oxides, that means which are ionic, right? They are mostly ionic. When it comes to the scandium, because of the small size, remember when cation is small size, you could anticipate that to be covalent. All right. Next, the highest oxidation number of the corresponding to the group number is transition metal is obtained scandium to manganese. You have studied from +3 to +7. Correct. Incorrect you need to identify, right? Next, see, basic character increases from V2O5 to V2O4 to V2O5. We are talking about here increase in the oxidation state, +3. All right. All right. You can see here +3. What is the oxidation state here? +4, and over here it is +5. As you know that when oxidation state increases, you all know that acidic strength increases. Acidity increases. So, C looks to be incorrect, and V2O5 dissolves in acid. Remember this. You see, how would I identify that, sir? See, very simple. Oxidation state of vanadium you have to find out. 4 into oxygen is -2 equal to the total charge, and the value of X is turning out to be how much? +5. That means in the parent compound, the native compound, the oxidation state of vanadium or any compound when asked like this, when dissolved in acid, remember it is not a redox reaction. It is a simple bond cleavage reaction. So, oxidation state should not change. So, in VO4 -3, if oxidation state of vanadium is +5, in the starting compound also should be +5 only. So, it is vanadium pentoxide that gives rise to the vanadate ions. All right, buddy. Okay, hope you understood. All right, so this is how we understand actually. Otherwise, how would I know these many reactions? How can I remember? So, this question is almost impossible, buddy, without this proper knowledge. Please understand one thing which I wanted to tell you. Basic character will not increase with oxidation number you have studied. Acidic character will increase with oxidation number. That point will tell you the story here. And here when it is formed, the salt is formed, whatever oxidation state your salt has. For example, let me tell you another reference. You have say orthoboric acid formed when some of the compound of boron reacts with HCl without changing the oxidation state is nothing but borax, because in both the cases the oxidation state of the boron does not change. Alright. So incorrect are these two, whereas this is purely, CRO is basic. Cr2O3 is amphoteric, it reacts with acids as well as bases. This question is interesting and little bit controversial also. Let me explain you why, because you might have come across this, Rajalakshmi, and let me explain you why. When we talk about the dehydration, please understand, dehydration reactions are favorable when there is electron withdrawing group. Remember this. Or electron releasing group. Can anyone tell me? How would I predict whether I need to take electron withdrawing or electron releasing? Can anyone answer to this? What should be there, Anish? Withdrawing or releasing? Which group should be there in the compound? Dehydration. Dehydration means removal of water. Which group should be there? When I am removing water, that means I am removing OH. Look at this. When I am removing OH, what is that I am getting? What is that I am getting here? Plus. What do you say, buddies? Carbocation, isn't it? Vaishnavi, can you hear me? Will you please tell me? Isn't it the intermediate that is formed during the dehydration? Alright, so carbocations are stabilized by electron releasing groups. Yes, very good, Anish. Acid dehydration follows even mechanism, producing what? Carbocation intermediate. Carbocation is stabilized by electron releasing groups. You can see simply all these options have NO2 in them. And when it comes to NO2, you have studied that it's a very strong electron withdrawing group. Therefore, it's obvious that the answer is B, brilliant. And not only that, when I am removing here, you are getting a conjugated system. The product is at most stable. That's the reason, without any bias, the answer is what? Option B, Bombay. Hope you understood what you all say. Alright, what is electron releasing, Anish? Please correct yourself. Alright, Vaishnavi. Yeah, this is another important part. See, one must understand, you cannot break the bond of benzene with oxygen or halogen like chlorine that easily. We cannot break it that easily. May I know the reason? Varshini? The reason is very simple, beta. The reason is very simple. There is a strong resonance. So it's not so easy to break these bonds. It's not so easy to break them. So can you hear me, buddy? Yeah, I'll try to increase the volume from my end. Also ensure that you raise your volume up. Now my point is, when there is a direct connection between the benzene with oxygen or halogen or nitrogen also. Even I can take what you call nitrogen. They all have the resonance existing with the benzene. This is what you called as plus M effect, mesomeric effect. So that bond will make, that effect will make this bond stronger. So you cannot break it no matter what reagent you take. So if you want to break a bond, break adjacent to it. And oxygen gets minus, carbon gets plus, because oxygen is more electronegative. That's all. Hydrogen is plus, iodine is minus. Attach the opposite components. Plus with minus, CH2I, minus with plus, So right answer should be, hope you all have said it right. Anish, great going, but Vaishnavi is correct. Resonance is the reason, isn't it? Simple as that. Alright, buddies. Good. Now you see the reaction that does not take place in a blast furnace. You can say metallurgy, we can leave. Yes, certainly we can leave. But let me tell you that this is the answer, because this reaction occurs at 800 to 500 Kelvin. Remaining reactions will occur in, this reaction occurs at 500 to 800. Alright. Which among the following, this is a direct question, delta H, delta U relationship. Oh, Manish, you wrote last year. That means there is a lot of improvement in your preparation, buddy. Good going. What's the answer then? Anish, delta H equal to delta U plus, that's it. Delta N RT. What is delta N here? Number of moles of gaseous products. You need to consider only the gases, because these concepts are applicable to the gases only. Gaseous products minus number of moles of gaseous reactant. You should not take the other compounds, isn't it? Yes, good. Alright, consider only the gases. Good job. Now you see balancing of redox reaction. Let me give you one simple method of balancing this complication. Okay, section B question last year. So let's see how do we balance this equation. I'll give you a simplest method to balance these equations with least effort, less time also. You see, this is the equation that on the whole mentioned to you. Any equation may be given to you. I'll give you the shortcut to balance it. You know, you have been studying what you call n factor, isn't it? N factor, the concept of n factor, I'll tell you where I teach. N factor, the concept of n factor, change in oxidation number, isn't it? Change in oxidation number is nothing but the n factor. Do you know that? Yes. Chromium oxidation number is how much? Plus 6. Do you agree? Do you agree, Vaishnavi? Yes. Plus 6 to plus 3, what is the change? Plus 6 to plus 3, what is the change? 3 units. But how many chromiums are there? 2 chromiums are there. 1 chromium to change from 6 to 3, it requires 3 electrons. There are 2 chromiums, so n factor for this compound is 6. They might also ask you the equivalent weight. You know that equivalent weight is equal to molecular weight by n factor. Remember this. Now you see sulfur is from plus 4 to plus 6. The change in oxidation state of sulfur from 4 to 6, that is 2 units. So always remember, after finding out the n factor, invert the n factor ratio to get the mole ratio. Invert the n factor ratio to get the mole ratio, Vaishnavi. What is the n factor ratio? 6:2 means what? 3:1. N factor ratio 3:1. Invert it, you will get the mole ratio. That means this gets 1, this gets 3. That's all. There are 2 chromiums here, can you see? There will be 2 chromiums here. There are 3 sulfurs here. There are 3 sulfurs here. That's all. Now you look at the oxygens, 9 here. Alright. 9 plus 7, 16, and over here 12. So you will be writing 4 and 8. So right answer is 1, 3 and 8. How many of you have got it? Varshini got it. Excellent. So using the n factor, you will get the answer in less than 1 minute time. If you don't use n factor, it might require little extra time. Shall I give you one more question on this? Will you balance? Will you tell me the coefficient very easily? Out of the box, which we are trying to do, isn't it? Chalo, we will do that. I'll do one thing. I'll give you one question. Try to do that. MnO4 minus oxalate, it was asked previously. H plus, manganese plus 2, carbon dioxide and water. So these are the products of this reaction. Let's use n factor method. Come on, tell me quickly. Say along. Manganese ka plus 7 to plus 2. change in oxidation state will be how much? 5, isn't it? Great. Carbon plus 3 to plus 4, plus 3 to plus 4 change in oxidation state is 1 unit, but there are 2 carbons. Got the n factors? Yes, Vaishnavi, this is 5, this is 2. Is that understood, all of you? Anish Bede, do you hear me? Aaya samajh mein? Yes, so n factor ratio is 5:2, mole ratio will be 2:5. Done, dusted. Because once if you know this, you can write that side 2 manganese hai, so that side 2 manganese, you can say 10 carbons, total number of oxygens. Look at this, 8 plus 20, 28. This side you have only 20, you have 8 here and 16 H plus. Using n factor can fetch you the solution within no time, buddies. That should be your intent. Is that understood? I hope you students who are following up the class thoroughly, this method will be helpful to you in solving any number of questions. This is again from solid state, let's ignore. Alright, it's a theoretical question. Nutrient deficient water bodies lead to the eutrophication. It's a theoretical question. Alright, and eutrophication leads to the decrease in the level of oxygen in water bodies. Both are correct statements. Theoretical question hai, NCERT mein milega. Okay, you can see equilibrium concentrations of ABCD are given. Delta G naught is asked. Thermodynamic connection with RT log of K. Just substitute. You will see most of the time the calculations will be simple. R value, look at the units and they will give you R value. Need not mark up. Into temperature, right? Temperature would be mentioned to you 300 Kelvin into log K. The equilibrium constant for this reaction would be concentration of C into D by A into B. Just to substitute these values to get your answer, isn't it? Alright, you can see C value is given to us how much? 10 into 6 by 2 into 3. So your 6 gets cancelled and log 10 becomes equal to 1. Yes, brilliant. That's all right. Now I guess this is the right answer base, because you can see 6 and 2 point something is 1380 and there is a negative sign also. Alright, most stable complex is asked. Come on, what is the answer, buddies? Quick, Vaishnavi, is that answer for this question, beta? Varshini, Anish, क्या खास है? What is significant here? ये तो special ఉంది చూడండి. See, yes, brilliant. What made you say that? Anish, could you please say something? What made you say that? The ligand makes his... Oh, reason is nothing but the strong field ligand. One should know that pi acceptors and chelating ligands. Pi acceptor and chelating ligands are regarded as strong field ligands, isn't it? You know the structures of these compounds, right? How would I know the structures? You see, simple, boss. You please write the answer to what you know already. You know sulfuric acid, isn't it? First, let's write sulfuric acid. Whatever we know, we will write them first. Alright, sulfuric acid. Yes, I know sulfuric acid. Write that first. Why you are behind the compound which you don't know yet? Next, you have sulfurous acid. That means what? One oxygen less. One oxygen less. H2, SO3. First, you pick up these two. You guys can see. Then you will be able to find out the remaining. Okay, but that's okay, no? When you can make out this thing, you can work out on the remaining, isn't it? What do you say? Sulfurous and sulfuric anyways, you know. Then the remaining two can be easily ascertained. That's what you need to do. Remaining two is nothing but peroxodisulfuric acid. That means two sulfuric acids are connected to each other by a peroxy bond. You have studied this in the oxidation states. And the other one, the last one, is pyrosulfuric acid, where one oxygen, pyro, comes from sharing It's a Latin word. Sulfuric, no? Sulfuric, sulfur. One oxygen is being shared. That's all. When you know this, you can easily find out the answers. Alright. And lastly, pumic stone is an example of solid soul, right? Air is present inside the stone. Solute and solvent combination which makes it the solution, right? Pumic stone, which has small pores, which you will see at the seashores. You will find the same in your NCERT textbook in the table which comprises various types of solutions. In solutions chapter, liquid solution chapter, you will find this. See how simple the question could be. Alright, hope you guys had fun in learning, right? Stay tuned, see you tomorrow, same timings. Alright, tomorrow we are going to discuss some more concepts and so much theory. And thank you for being with us, Kasarapu Rebecca. Thank you for the compliment. The paper last time, but pressure was hard. I understand that. You need to understand the basic thing. Under the immense pressure, water droplet converts into the pearl. Without pressure, the earth is not going to survive. Pressure is good, but only when you handle with peace of mind. Now you are matured enough. Now you are focused enough. I'm pretty sure that if you maintain the same, you're going to definitely crack the examination. But remember, buddies, one last thing. We will commit a mistake in the answers which we already know. They are known as silly mistakes. So please check twice before you move to the other question when you have marked one answer. Alright, good luck. See you tomorrow. Stay tuned. Thank you.